This music just makes you feel weightless, doesn't it?
It ought to.
This is Sci-Fi Overdrive on Business Talk Radio. I'm Dave DeRica, your chief engineer. That deep voice you just heard was Eric Lindstrom, the science giant.
Good evening.
This music's great. We need to pick more songs at random. This is actually from Vic Mizzy, Sweets and Themes. It is from The Reluctant Astronaut.
Starring Don Knotts.
Yep. Anyway, Eric, what are we doing tonight on this program that documents science fiction and science fact stranger than fiction?
Right. Well, Valentine's Day is almost upon us, and as we all know, men are from Mars. Women are from Venus, but men are from Mars, and so I thought it would be entirely appropriate to bring one of the men who got us to Mars on the program. We're going to be talking with Erik Bailey, who's a system engineer for the Mars Exploration Rovers Spirit and Opportunity. Welcome to this broadcast of Sci-Fi Overdrive, Erik. It's great to have you on the show. Let me first get an update from you. We know that Spirit had some problems with its flash memory.
Yes.
How's the spacecraft doing now?
It's doing quite well, actually. Mark Adler, one of our mission managers, reported this morning that it's well on the road to recovery, if not almost completely there. Today we were going through an exercise to reformat the flash and basically make sure that there are no little gremlins in there waiting for us to uncover them and go back into what's the equivalency of a safe mode for our rovers. So, but things are going extremely well, and we believe that Spirit should be back to full scientific operational capability within a few days.
Okay, prognosis sounds really good, but as a system engineer, I imagine that it was your responsibility to track down the problem being not with RAM, but with the flash memory, not being a hardware, but being a software, correct?
Actually, there are a lot of systems engineers that work on this project. I focus on the entry, descent, and landing system. And
6 minutes of pure hell.
Yeah, there's a whole dedicated system or dedicated series of people that are working on the rover itself to make sure that they're running okay. But in the meantime,
we're back on this broadcast of Sci-Fi Overdrive, and we continue our conversation with Erik Bailey, an MIT-trained engineer who now applies his brains to the Mars Exploration Rovers as a system engineer. You were working on the descent and entry and landing portions for the Mars Exploration Rovers, and one of the problems was it wasn't quite so simple as just taking the old Pathfinder model from 1996 and just blowing up the airbags a little bit more, was it?
No, it wasn't, and we were hoping it would be. When we originally started working on the system, we were doing what was called build to print to save money, and we found out as the rover kept getting heavier and heavier and heavier that both the airbags and the parachute weren't quite cutting it. And the airbags themselves, we went and tested the Pathfinder design, which had, I believe, 4 layers of fabric and 1 bladder, and we tested it with the proper weight in the proper pressure environment in the Plumbrook test facility near Sandusky, Ohio, and the airbags kind of sliced right open, and you can see gaping holes and stuff in the bags in the slow motion video, and it was very scary. And it caused us to work with ILC Dover to actually redesign those bags, and we actually now have 6 layers of Vectran with 2 bladders on the inside, so they're much more sturdy, and we were able to expand our capability of airbag landings by pushing the envelope with the mass, even though it caused a lot of heartburn for a while. The parachute was another thing that we had an issue with. I don't know if you're aware of that. The parachute design is a Viking heritage that was modified for Pathfinder, and we were going to use that same design, but it turns out that the parachute, under certain conditions, would actually kind of like blow up on us. I mean, not just inflate, but like shred itself. And we actually had to go back and redesign the materials and the stitching and make sure that things were okay. And then after we did that, we put it into a wind tunnel to test it, and it didn't blow up, but this time it didn't inflate.
Oh.
So then, you don't want to come down to Mars with a streamer behind you. So
yeah.
We basically had to go back and found out that the vent hole was too large. So we actually closed the vent hole, and actually then now the parachutes would inflate right on command and the time allotted, and based on the data that we got back from Spirit and Opportunity, the inflation times were right on the money, exactly what we expected in the Mars atmosphere, and the parachutes performed beautifully.
Well, let me bounce around off those two things for a second. First of all, in as much as not having the airbags inflate, I guess a lot of people probably have a visual image from Red Planet, the movie that starred Val Kilmer, which if you've seen, they are descending to Mars, and one of the airbags ruptures, and as a consequence, a guy cracks a rib, and everybody gets banged up pretty badly on the way down.
Yes.
So what exactly are the airbags made out of? You mentioned a substance which I'm not familiar with.
Vectran. It's a lot like Kevlar. It's a material. It's woven into cloth, and it's used in bulletproof vests and other types of technology. We use two really cutting edge fabric technologies on this mission. Vectran is one, and Xylon is the other one. And Xylon is also like Kevlar, but it's more sensitive to ultraviolet exposure, but it's stronger than Kevlar, if you can believe that. So, and that's what we made our bridle out of, which is what we attached the land. It's what we hung the lander from beneath the backshell, which contained our rocket motors.
And of course, the little red LED that goes back and forth above the ice slot. Oh, I'm sorry, that's Cylon, not Xylon.
Yeah, right. But no, it's definitely. I mean, we used a lot of interesting materials to get this done, to get this mission done.
Commercially available?
Yeah, they all are. You can go out and order it if you want. It's not cheap, but you can definitely go do it.
Well, I wasn't exactly planning my own Mars mission, but but if you were a science center, if you were a museum, a planetarium that wanted to say, see guys, this is what that airbag's made out of.
Sure. Yeah, you can go get a swatch.
Which leads to the next question. I mean, you probably had seamstresses. You had tailors who actually sewed up the airbags.
Oh, yeah. That's ILC Dover, which is the same company that makes the spacesuits for the astronauts, is who constructed our airbags. And they also, I believe they also constructed the airbags for Beagle as well. So they're like in the airbag and spacesuit business. They did Pathfinder, they did Murray and Merbee, Spirit and Opportunity, and they also did Beagle as well. So the airbags are...
You know, we're back on this broadcast of Sci-Fi Overdrive, and we continue talking about the now, once again, healthy and fully functional Mars Exploration Rovers. Although the real question, getting them down to on the surface of Mars, not something done every day. You don't land on another planet every afternoon. So how did you effectively simulate having a much thinner atmosphere?
Well, testing the entry, descent, and landing system was a very, very difficult task to do. It involved a lot of different test sites, and because you can't test it end to end. I mean, you can test individual components, like for example, the drop chamber where we tested the airbags. It's a huge vacuum chamber at the Plumbrook facility near Sandusky, and the parachute we actually tested in I believe it's the Transonic Dynamics tunnel at NASA Langley, where they can also pump down as well, and it's basically a vacuum chamber as a partial vacuum chamber, so you can reduce the amount of fluid flowing through the tunnel, and they do that to match Reynolds numbers and get appropriate speeds for aircraft. But it was also appropriate for testing our parachute as well. And that's basically what we do. I mean, we test all the components individually, and we just make sure that all of our tests have a certain amount of overlap, so that overlap ensures that we get the right dynamic characterization of how the things will perform. And then we have we mentioned earlier that we have a test bed here on lab. We use that very same test bed to test how the rover's computer was going to control the entry, descent, and landing, because we can't do anything real time because the one-way light time to Mars is longer than the entire EDL sequence.
Right.
So the testing that we do led to data. The data then led to models. The models then led to simulations. The simulations then led to basically more data that was fed into the test bed, which is essentially like a virtual reality for the computer. So we'd fake the computer out to thinking it was landing on Mars, and then we would characterize how well the system performed given those excitations. So it's this big, involved process of many, many layers that are all interconnected. That it's very important to make sure that you, again, dot all your I's and cross all your T's, because there's, if one little hole in that little sequence, and you could think you're absolutely fine, and next thing you know, you're not hearing back from the rover once it tries to land on the surface.
But NASA would never fail to convert newtons into
pound force.
Yeah.
Yeah. No, that actually is a classic example of some small detail falling through the cracks when you're under a lot of pressure. That particular program was being pressed for both time and money, and they just pushed too hard, and they started missing the details. And when you miss the details, that's what makes you lose missions. So we backed off from that philosophy after that. We reorganized how we were doing things, and we took a completely different approach with these two rovers, and so far so good.
Yeah, it's like the sign in the car mechanic shop says, faster, cheaper, better. You can have any two. Mm-hmm. Faster, cheaper, not better. Better, cheaper, not faster.
That's right. And actually, we had a saying at MIT that was very similar too, which was, you can get good grades, you can have a social life, or you can sleep. Choose two. So I'm very familiar with dealing with things like that. And the aerospace business is nothing more than an elaborately constrained trade problem. I mean, you're always constrained in mass, volume, power, payload capacity. The ability to go to certain planets with certain launch vehicles that are, because you only have certain launch vehicles available to you, things like that. And it's always a trade-off between all these things, and you're constantly weighing these things back and forth. And when you start heavily constraining one of them, you can bet that it's going to roll over into other aspects of the mission. So faster, better, cheaper in principle was a good idea, but in practice it actually was not that good.
One last question before I move off this topic. You guys had it timed down to exactly when the retro rocket would fire, exactly 1 second before it came down. Why didn't you give yourself a little more leeway of 2 seconds or 3 seconds?
Well, the way this system works, as I said, we're constrained in volume and mass and all these other things. The retro rocket system, in order to fit inside the back shell system, we could not use a liquid propulsion system to have more control over what's going on, which means we had to use solid rocket motors. Because we're constrained in volume, the solid rocket motors are then constrained in size, which means they're constrained in how long they can burn. So, you've probably seen there's an animation that's available on our website of the terminal descent phase of our landing, and you can see this thing screaming at the ground at about 150, 152 miles an hour, which is faster than free fall of a skydiver here on Earth.
And actually, I haven't given the website. Let me say it's marsrovers.jpl.nasa.gov. I'll give it again when we come back from this commercial break as we continue our conversation with Erik Bailey. Do stay with us. During this hour of Sci-Fi Overdrive, it's been our privilege to talk with Erik Bailey. He's an MIT grad who's gone on to work at Jet Propulsion Laboratory, a.k.a. California Institute of Technology, for the Mars Exploration Rovers. I'm a little bit curious, Erik. Take a look for the future. Your systems that you're working now will probably have a role in putting man on Mars, getting reluctant astronauts out to the red planet. If the country follows President Bush's vision, you talk a lot about using the heritage design from Pathfinder. Now your work will be a part of the heritage design. What's next on your drawing board? Are you looking at 2015 and getting men to Mars?
I personally am not looking at 2015. I'm moving on to a project called the Mars Science Laboratory, which is slated to launch in 2009. And it's going to be, our rovers are roughly the size of a golf cart. These next rovers are going to be roughly the size of a Volkswagen. They're going to be another step up in size and therefore another step up in mass. And the airbags are pretty much at their capability of being able to deliver mass safely to the surface. So we're actually looking at a new type of landing system, which is called the Sky Crane, which actually has a liquid propulsion middle section that's like our back shell that actually can go down and hover and then slowly drop the rover down onto the surface while it's hovering and then fly away. Yeah.
Wow.
Yeah.
Is hazard avoidance that good at this point?
Yes. That's one of the key things that this mission is going to be able to demonstrate is hazard avoidance. Both that and the ability to deliver the payload from an interplanetary trajectory to within an ellipse that's like 5 to 10 kilometers big, whereas ours on MER was about 40 kilometers big. So
right.
It's a factor of 4 reduction or more in the navigation delivery and active hazard avoidance to avoid boulders and rocks and craters and things like that.
2009 going to be prepping for a sample return mission or just additional analysis?
No, it's additional analysis. Sample return is is an order of magnitude more complex because not only are you landing a rover on the surface to go do science or even just a static lander with an arm, you also have to land an entire launch system to get it back off of Mars again and get it back to Earth. So you basically have to land a little miniature version of KSC or Kennedy Space Center. On Mars and then take off from the surface and bring back to Earth. It's a very, very ambitious task. We are looking at doing it because, that type of thing is going to be needed for when we send humans to other places in the solar system. And one of the key technologies for that is called in situ propulsion development, and that actually will take water or carbon dioxide or the chemicals that are around you wherever you are and make your fuel once you are actually at your destination, so you don't have to actually take the fuel you need to get back with you when you go.
Right.
So that's actually a technology that the sample return mission wants to demonstrate as well. But the sample return mission, I don't even know if they have a year tacked on that yet, because it's been proposed ever since back in the Viking days, and it's so ambitious that I don't think we're ready for it yet. We still have to take some baby steps before we go to that route. But it's very exciting what President Bush has lined out for exploration, and he did mention robotic exploration as being a key hand-in-hand component. So I believe you're going to start seeing more robotic technology that could possibly be reused or revived or continue to be used once humans get there. So you're going to actually start seeing a more integrated development between the robotic end of things and the manned end of things. And obviously he just announced that last month. So the plans and the shakeup from that announcement are currently still going on.
What do you think of telepresence? Do you think by 2009 it'd be possible to slip on a pair of virtual reality goggles and let kids feel like they were actually driving the rover on the planet Mars?
Well, I mean, we're almost there with telepresence as it is now. We have the ability to do the three-dimensional goggles like they have in many IMAX theaters around the country with the liquid crystal flicker, and we can look at our rovers, because it's binocular vision. We can look at what the rovers are seeing in binocular vision, and it looks like you're standing there on Mars looking at this stuff in 3 dimensions, and it's absolutely astounding and breathtaking.
And as we wrap up this broadcast of Sci-Fi Overdrive, we turn our eyes from sci-fi and science facts, stranger sounding than science fiction, to the sci-sky. And for the sci-sky, we turn to Stuart Goldman, associate editor of the Essential magazine of astronomy, Sky and Telescope. Hello, Stuart.
Hello.
It's great to talk to you again.
Yeah, it's been a while.
You've gotten your driver's license, so...
Yeah, it's all renewed.
Tell me about having a driver's license for the sky. What's up, so to speak?
Well, we still got a lot of good planets to go out there and look at. Saturn's actually moving more toward the early evening, better placed as soon as it gets dark. And also as soon as it gets dark, even before it gets completely dark, you undoubtedly can notice Venus in the western sky, big and bright.
Yes, indeed.
It's going to be there for a few more months. So, evening star for most of spring.
So then Mars is still up there too, right?
Yeah, it's over there in the west, getting a little bit. It moving slowly, but it's getting dimmer. Still worth a look. You can see it's gibbous phase.
Of course, no real sense in looking at Mars just with your eyes when you got the Mars Exploration Rovers on the ground sending real close-up pictures of it.
Right, nice panoramas are sort of fun to zoom in on. I don't know if you guys talked about the interesting, the Mars Exploration website that NASA has. Really cool tools that you can use that are sort of off-site from JPL. One of them's Mars Quest, and it has they incorporate the latest pictures into this image browser of sorts. And it's really fun to play with because you can bring up an image and then pan around and zoom in on the rocks that they will eventually name, and you get a directional overhead view. So you actually see which direction you're looking in.
Wow.
And I like saying, can you see this hill on this map? I don't know. Pretty cool stuff. I'm waiting for the next months and months of data to come out of these things.
What's the reaction at Sky and Telescope Bend with President Bush making his address to return a man to the moon before the decade is out and bring him back to Earth and going on to Mars? I mean, do you sense that there will be a new interest in astronomy, or are you kind of a little disheartened by the way I hear people say, what are we wasting money on space for?
Well, it's a mixed bag. I mean, having a goal to go to Mars is pretty exciting, but the things that are coming with it, like we're going to finish the space station and then just get rid of it. So why are we building the space station?
Because if you started building a model, darn it, you're going to finish it, because we spent good money on that kit.
It has, no scientific value, and it's just, I guess the what I've heard is that it's to be to acclimate living in space long. Well, I guess if you want to just fix machines for days on end, but it's an interesting proposal because getting to Mars is going to be pretty tough. There's still some technologies they have to develop to even do this.
I suppose one of the most breathtaking announcements, though, came from that the Hubble Space Telescope might have to be sacrificed to get people out to Mars.
Yeah, it wasn't linked in that way, but some people are kind of thinking that it actually was.
Well, servicing mission number 4 would be canceled in order to not place astronauts at risks and in order to conserve money.
Right. But the money's already been spent. As somebody, another fellow editor says, each shuttle mission, the shuttle program costs so much money per year, whether they fly or not. And if we actually launch something, it's no more money to do it, because you still have the staff and everybody else that has to take care of things. So it's not really a cost savings not to fly the shuttle, as long as you still have the program.
And we certainly get a great return of investment from our photographs taken by the Hubble Space Telescope. And that's why people read Sky and Telescope magazine, to see the glories of outer space. Stuart Goldman, associate editor of that essential magazine of astronomy. Thank you so much for joining us on this broadcast of Sci-Fi Overdrive.
You're welcome. Thank you.
Talk to you in a few weeks.
This has been Sci-Fi Overdrive on the Business Talk Radio Network. We now return to boring things.